Hello everyone, today we will continue with the bed assembly, and first of all I decided to mount the thermistor for the bed on the aluminum plate itself. This is totally not necessary, but I just want to go in that way. So for that, this part will be the back side of the bed. So I drilled it and also drilled on the bottom side aluminum plate and thread the hole, and with that way I'll use the thermistor that came with the kit as a bed thermistor. So this one will be placed inside this hole like this, and when I tighten this screw a bit, it will hold this in place. And of course I need to configure also clipper, that will be mentioned while we are doing it. And another thing, we need to drill at least one hole, or depend on your choice, 2 holes. What I'm trying to say, we need to put what do you call this, thermic fuse. Yeah, thermic fuse. If I can find one of them. Yeah, these thermic fuse are used for to cut the current when the temperature is higher than the nominal value of the thermic fuse. So in our fuses is rated by 125 degrees. So that means if the bed temperature is higher than 125 degree, this fuse will be will cut the current. So you will be in the safe. There will be no fire. This one. So this is rated 125 degree. So once the bed is higher than, the bed temperature is higher than 125 degree, this will not be any conductive, so it will cut the current. So previously they were installing this one on the aluminum plate itself, but later on with using high temperature silicone RTV, now generally they are putting this fuse on the silicone mat itself. So in that way they are saying that if the silicone mat the glue is not strong enough and it's dropped, since the fuse will be sticking on the silicone mat, so again it will get the right temperature. But if you put this again aluminum plate and your silicone mat is dropped, so obviously your silicone mat will not heat your aluminum bed, but again it will get the data from the aluminum bed, this cast aluminum, what I mean. So also I will glue this fuse on the silicone mat itself with the RTV, which is high temperature silicone, this one. But at least, like I said, at least we need one hole. It's for the earth connection, so you have to connect earth to your aluminum bed. For that, before I put in my silicone mat and spring plate magnet sheet, I will drill a hole, and with 3mm screw I will put a earth connection with, I don't know, they provide it, I think they not. Let me show you the connector. With this terminal, drill a hole, tap it with the M3, and I will connect the earth connection with this terminal. So the screw will go inside this terminal, so there's no chance to the environment that is not touching the aluminum plate itself. So these are the safety features, by the way. And since I will use M3 3mm screw, I will drill hole with the 2.5 drill bit, and after that I will use my thread thinner. What is it called? I don't know. These tabs for the create a thread. I place this dot while I'm putting the heat mat in roughly position, so it will not interfere with the silicone mat. You know, before you drilling, it is a good habit if you punch the material. So I don't have this fancy puncher, but I will use this screw with my hammer. So with that I will create a little notch on here, and it will help me to drill in the right place. It will not, my drill will not oscillate and screw the bed. I will use M3x6 screw. For that I will put a mark on my drill bit, so I will not drill more than enough. Now I know how much I need to drill. Slowly I will drill it, and of course you want to, since I don't have a stand drill or something, I'll use my cordless drill, but I'll be careful about creating the 90 degree between the cordless drill and the place, so in that way you will do the proper job. So don't go fast on it, and little bit WD-40 will help you, but yeah. I'll come back and clean the excess aluminum. Now it's ready. Now I need to create threads in there. Remember, we will thread in M3 3mm, so I use 2.5 drill bits. So you need to go lower 0.5mm while you're drilling for tapping. Again, you want to be perpendicular with the plate. Now I will clean the bottom surface and stick the silicone mat on it. Again, I will use isopropyl alcohol. Now I will again clean the middle part with the isopropyl alcohol. I will heat it with heat gun a bit. So you need to take off a little bit, not that much. So with that we will do the initial sticking. Don't take off whole the way because it will be harder. So just we will go by part. So little bit take off and align it with my marks. And yeah, gently giving pressure. Now again, small amount, and stick the middle part, go to the sides because we don't want any bubble. We will complete the whole vat like that. We will go part by part. Okay. I'm just sliding the thing a bit. Pressing in the middle, go to the sides. Yes. Seems nice. I will clean these marks. So I use pencil, so it's easy to remove on the aluminum surface. It does the job and you can just remove it. We will put also the magnetic sheet. That's one, but I'll use a soft place since these are this thermistor and this cable connection is higher than the normal bed surface. I want to be careful about that. I don't want to break anything inside it, so I will use soft surface for that. Is that part? We know that because screw. We will do our initial cleaning. Like I said in the unpacking video, my bed is 305 millimeter, so there will be 2.5 millimeter gap between not between in every side. So I want to stick my magnet on the middle of the aluminum part. So again I will mark it. Our magnetic sheet will be placed roughly like that. Again, I will clean the bit. Again, we will use same method, take off a bit and go part by part. And I took just a little bit. And tries to align with my marks. Corner should be okay. Okay, in the middle. And be careful about this magnetic sheet. If there are small pieces of, for example, PLA or ABS or something else, little rock, but just small pieces, huh? These small pieces can cause a damage in your magnetic sheet. These are a little bit soft. If there is some small pieces on your sheet and you place your spring steel on it, due to pressure, these small pieces will create a damage in your magnetic sheet. So before you're placing your spring steel, always just check your magnetic surface of your magnetic sheet. Also, while you are doing this, careful about that. First I'm sticking the middle part, then I'm going to do sides. It seems nice. I'm happy with it, except this screw part. After sticking your magnetic shield or silicone mat together, you need to apply pressure for 24 hours and let it dry. So for that, you can use any material has weight and put on it. But I have a clamp, so with woods and all, I will clamp it together and let it dry for 24 hours. So careful about this. Now, with the help of these fabrics, textile fabrics and the woods, I will clamp this sandwich, we can say. Like I said, I'm using these fabrics because there is a height difference between the mat itself and its resistor and the connection side. So I don't want to break anything. So I'm creating another. I'm actually compensating the height difference with these fabrics. Now I need to turn it. I put the bed aside to cure its sticker, its glue, and now I will continue with the Z Endstop suite. But before that, the clamp didn't work. It created a bend on the middle, so it won't giving the pressure on the middle on the plate. So I used the old classic method. I just put the weight on it. After putting the wood, I added weight. Literally, I put the rock actually. So now I will wait 24 hours. After that, I will apply this high temp silicone. Now we will continue with the Z Endstop pin. Like I said, first you need to deflange the 20-tooth pulley. So you need to remove this cap. So I already did with my plier. This one. Another thing I realized, now the sourcing guide is saying we need 30mm shaft. This is the 5mm diameter rod for the Z Endstop, but on the manual it's saying 33mm. So it turns out if you are using spring steel and the magnetic sheet, so you need to use the 33mm long rod. I'll buy another rod and cut it in the 33mm and I will use that one. And also for the rod, we will create a notch with the file. And I learned that, I didn't know also, I learned that this is for actually useful while you are doing maintenance on your print. The concept is that this rod should move freely in here. For example, this one also that came with the kit is not moving freely. So what I will, with the cordless drill and sandpaper method, running like this, I will just reduce this diameter of this rod to move it freely on the pulley. Imagine that it's connected to your frame, your printer, and you are doing the maintenance. When you turn around your printer, it will drop easily because it needs to move freely to press the switch, which should be placed in here. So for that, we need to create a notch somewhere in the middle with using the screw. Little bit, we will tighten a little bit the screw, grab screw, and with this notch, it will again move freely, but it will have limited movement. So it needs to be have distance to press the micro switch and come back to its zero position. Just sticking on the micro switch, what I meant. And since it will have notch, it will not drop when you turn around or while you are doing the maintenance on your printer. However, I will do this on the new rod tomorrow after I bought one. And for now, I just flange my 22 gear, pull 22 pulley, and now I need to install micro switch. So let me find it. I found the micro switch. It will placed in here, but first we need to remove this part, this metal part. I will just bend it. Yeah, with the I will check just to be sure before installing it with the continuity test. We will use normal closed. Yeah, it, and when I press it, it should not be beeping. Yes. Yes. So just to test it. Yeah. Yeah, actually the diameter of this rod also is fine. As you can see, after clicking it, it's coming back. So it's not stuck in clicked position. We want it like that. Yeah, that's nice. So we need to mount this micro switch with M2 self-tapping screws. We don't have to torque this. It should be just snug. Yeah, remember when you are threatening the plastic part itself, you don't want to go hard on it, because you can, trying to torque it, you can pulverize the plastic part, so the screw will not hold it to plastic. It will be worse. Now I will try again. Yep. By the way, this module will be used for the determine the Z position, Z offsets. So after doing quad gantry, your nozzle will come on this place, which we will adjust the place while you are doing the software configuration. So nozzle will came on this spot, and until it's clicking it will come down in the Z. Once it clicks, it will know the Z0 position. So in basic, only you have to do one time the adjustment for the Z offset. After that, it will be done automatically, I can say. Of course, if you will change your build plate, since the thickness will change, you need to do again the Z offset settings. But if you will use your stock configuration, you only need to do once. You have two options. You can solder wire on these legs and run to your board, or you can just use these JST connectors, and I will use JST connectors. So it's ready, its place is ready, what I meant. Now as you can see, it has 3 legs. The purpose of that, it has 2 contacts, one normal open and normal closed. We want to use normal closed because it's fail-safe. What does that mean is, if your wire somehow is broken or something, it will assume that your switch is pressed, and it will, in this module's case, it will stop the Z movement. If you use normal open one, it's not fail-safe, like I said. Your Z movement will stop until your nozzle is pressing the micro switch, and you will not get this information since your wire is broken. So your nozzle will crash on this pin, and it will try to continue to go down. But in the normal closed case, like I said, if the wire is broken, it will assume the button is pressed and it will stop the Z movement. The reason of that, normal closed one always inducting what it's receiving until you press the button. Let me show you on the continuity test again, and also I will determine which one is normally closed one. As you can see, if it's not pressed, and it is closed circuit, which means the current is passing by the switch itself. When you use the normal closed one, clicker is waiting to interruption this continuity. So when it's pressed, I'm pressing it and it's stopping. So when it's stopped, it's interrupted. Like I said, clipper will understand that that is the nozzle is press the micro switch and it will stop the movement. So again, continue to assume that your wire is broken and it's not inductive again. It's like pressing the button, except you are not getting the right information, but you are on the safe side, safe. So you can replace your wire and continue to use again. So in that case, I will use this one, this pin and this pin. Let me show you the normal open one. It is not a closed circuit, but when I press the button, it's closed circuit. So yeah, closed circuit. Since it's open circuit, broken wire didn't mean anything for the software, but in here it does mean. It's the same with the pressing switch. As a summary, use the normal closed contact. It is fail-safe. It is a common practice usage in the automation system. It's a common practice in the industry using the normal closed one for this feature. Since these legs are not touching each other with the GSD and the micro switch, I will run short wires between them. Now, how to solder. It's while you are doing the soldering the cable, it's a common practice that solder cable first to get some solder on it, on the cable, and do the same for the target, I can say, and solder them together and wait for the cooling. It is not the best of mine, but normally while you are soldering it, you want to hit where you want to solder, and after that you want to melt your solder with the heat part, not directly on the soldering iron. This is the general rule, and with that you can make beautiful shiny solders. However, these parts, all parts are, I can say, it's a plastic. I don't want to heat in a longer time, so I just did quick dirty job and melt my solder on the soldering iron. So that's why it's a little bit messy, but I think it will do the work. And after do quick test with these two pins, I will just super glue this part. That's what we want. Do quick tests. Yeah, without cable it is a little bit hard. I will continue with the Z Endstop tomorrow after getting new rod. I got myself a Aluminium Rod. Again, this is the solid one, but the finishing is different. It's a gray color, but it's not important as long as it's doing its job. I got a little piece. It should be 33mm, but I cut it longer, slightly longer than 33. Now with file I will reduce the length to 33mm. Also I will polish this. It will be nicer, and yeah, it's easier to file it instead of cutting exactly at 33mm. It's doing the job, and it's I think the diameter is different. Let's see. This is 490, 498. So the thing is, actually, it's a good thing. We want it free like that, so it's dropping by itself. There is no friction. But the other one that came with the kit, it has friction. So if you use 30mm one with not using magnetic sheet and spring steel, I would recommend to you reduce the diameter a bit. So it should be like this one. It should be dropped by itself. So, and another thing, the I will also create a notch somewhere between. There's no to being precise about that. The only job is with this notch I will tighten a bit the screw, grab screw. The job will do in normal installing position. It should be pressing the button, but when you turn it, it will come a bit, but due to notch and the grab screw, it shouldn't fall off. Yeah, it is 33.3 I can say, but I will leave it like that. If it hurts I can do quick file again. Yeah, we need to create notch. I just put the mark where the notch placed roughly. Like I said, we don't need to be precise about that. As you can see, the grab screw is not tightened. I just screwed a bit to hold the notch, and it's again moving freely, but it's not holding it. That's what we want. Again, freely press, freely move, but it's not dropping. It has passed 24 hours. Now I will apply the RTV high silicone, and purpose of applying RTV in the sides of the bed, stick the silicone mat aluminum. There was a concern about that this silicone mat can be detached from the aluminum bed due to high temperature. It's recommended that using the RTV for the sides to gain extra strength for the aluminum bed and the silicone mat. So we will also apply that, and it's easy. I will just use masking tape. Ah, it stinks. I hate the smell of silicone. By the way, I think the soapy water also works on that. If you use soapy water, unlike me, now I remember, the silicone will not stick on your tools, so it will be easier to apply it, and most probably you will have more beautiful finish, which actually it's not important, but yeah, if you want it. I'll place my thermic fuse here. I will just bury it. I guess it will be okay. This also needs to be sit 24 hours to dry. After that we will remove the masking tapes, and I hope we will have more safe bed and nice looking bed. Let's see. Another 24 hours passed. Now I will remove the masking tapes and see the results. I actually tried a bit, so I will carefully remove them. Except the thermic fuse, we did a good job. Thermic fuse is stuck in here, so of course always functionality comes first. That was it for this episode. In the next episode we will do the ABE drives. You can subscribe my channel to follow my building videos if you didn't, and see you in the next one.